Hi students, in today's session I am going to explain you about body centered cubic structure. In body centered cubic structure we have to find coordination number, number of atoms after sharing with adjacent unit cells, relation between atomic radius and nearest neighbor distance, and finally we have to calculate packing fraction. With this you can complete this body standard cubic structure. In order to find body centered cubic structure, first of all we have to consider one empty unit cell. Now in this unit cell, already from the last session we discussed in the previous slide. If you are having any doubt in simple cubic structure, please refer my YouTube channel and verify simple cubic structure for getting clear information about simple cubic structure. Now in this body centered cubic structure there exist 8 corners are present. At 8 corners of the unit cell 8 atoms are present. So this is the first corner atom, second corner, third corner, fourth corner, fifth one, sixth one, seventh one, eighth one. In addition to the 8 corner atoms, one more atom is occupied exactly at the center of the body. Where is the center of the body? How can we identify? Means the center of the body means center of body diagonal of the total unit cell, which will give center of the body. Here wherever two body diagonals are going to intersected, at the intersection point body diagonal present. Now this is a intersection point of the body diagonal. At this point an atom present. This atom is called as body centered atom. Therefore in this unit cell there exist 8 corner atoms and 1 body centered atom. Therefore total number of atoms in this unit cell is 9. Now in this body centered cubic structure, the central atom, which is known as body centered atom, this atom is nearer and equidistant to 8 other corner atoms. Therefore coordination number for the body centered cubic structure is 8. Now we will discuss how we will get 8 is a coordination number. In order to calculate coordination number, let us consider the second diagram, that is middle diagram. In this diagram it is known as body centered atom. It is called as first corner atom. Okay. Now we have to measure distance between the first corner atom and body centered atom. Now these two atoms are which atoms? Corner atom and body atoms are in contact with each other. Therefore if we can measure distance from the center of the corner atom to center of the body atom, will observe distance is equal to A. Similarly you can consider another corner atom, that is equal to from the second corner atom to center of the body atom. If you can measure distance, so this atom also nearer and equidistant. Therefore second atom is a nearer and equidistant to the central atom. Like this you can calculate remaining all other corner atoms. All other corner atoms are nearer and equidistant to this body atom. Therefore we have 8 corner atoms. First corner atom, second corner atom, this is a third corner atom, it is a fourth corner atom, it is a fifth one, sixth one and seventh one. Eighth corner atom is behind this unit cell. Therefore this corner atom has 8 this body centered atom has 8 corner atoms which are nearer and equidistant. Therefore, coordination number for the BCC structure is 8. After calculating coordination number, next our aim is we have to calculate relation between atomic radius and nearest neighbor distance. In order to calculate relation between these two variables, we have to consider the third diagram. In this third diagram, we have to calculate the distance of the AH value using the triangle ADH. Now in this triangle ADH, we have to find diagonal. So where is the diagonal? A to H is called as a diagonal. So now in the case of ADH, again we have to apply Pythagoras theorem. So from this Pythagoras theorem, so a triangle ADH is equal to AH square, that is equal to AD square plus DH square. Now in this equation, we don't know the length of AD. We don't know the length of AD. So to find length of the AD, now we have to consider the triangle ABD. Now in the triangle ABD, we have to calculate AD square again by using the same Pythagoras theorem. AD square is equal to AB square plus BD square. Now substitute AD square in the above equation, we will get AH square is equal to, in the place of AD square, substituting AB square plus BD square plus as usual DH square. Now from the figure 3, we know that AH is equal to 4R and the length of AB is equal to, BD is equal to, DH is equal to A. Substitute the values in the above equation. So in the place of H, I am substituting 4R whole square is equal to A square plus A square plus A square, that is equal to 16R square is equal to A square plus A square plus A square, that is equal to 3A square. Now R is equal to root 3A divided by 4. Now to get packing fraction of BCC structure, first of all we have to calculate total number of atoms after sharing is equal to n is equal to, after sharing number of corner atoms will get 1 and number of body atom is equal to 1. This body atom is not shared by the any another adjacent unit cell. Therefore, total number of effective atoms or total number of atoms after sharing is equal to 2. In this equation, we got n is equal to 2. Now we have to substitute these known values like n is equal to 2 and r is equal to root 3a divided by 4 in packing fraction. Already we know that packing fraction is equal to, now I am writing the equation of packing fraction. So packing fraction is equal to n into 4 divided by 3, n into 4 divided by 3 pi r power 3 divided by a power 3. This is a packing fraction definition. So we already discussed about the packing fraction definition in the previous classes. If you have any doubt, go back to my YouTube classes and refer the definition of packing fraction. Now in this equation, substitute n value is equal to 2 and the place of r, substitute r is equal to root 3a divided by 4. By calculating, we can get 0.68. Generally, packing fraction is calculated in terms of percentage only. Therefore, packing fraction of body centered cubic structure is equal to 68%. Example for the BCC structure is chromium, sodium and potassium are the example for the body centered cubic structure. My dear students, in the next upcoming class, we will discuss about the face centered cubic structure. If you do not have any doubt, please attend for the next upcoming session. We will discuss about the face centered cubic structure. If you are having any doubt regarding simple cubic structure or body centered cubic structure, please comment me in the comment section. I will give clarity for your doubts. Please watch my YouTube channel regularly For getting any updates, please share my channel, subscribe my channel and like my channel. If any doubts, please ask me freely. We'll discuss in the upcoming session. Thank you for watching.